Hello, class. This is Mr. Eggleston, and this is the discussion of lesson 4.5, determining the number of solutions algebraically. Okay, so we're talking about the number of solutions of systems of linear equations. Okay, so interpret scenarios with linear systems that have 0, 1, even though you can't really see it, there's a 1 here, or infinitely many solutions. What scenarios do you have with that? And then interpret scenarios, identify the algebraic structures that make a system of linear equations have 0, 1, or infinitely many solutions. All right, let me go down to here. I just want to explain graphically, what does it mean to be no solutions? So a system of linear equations with no solutions means you have two lines that never touch. So that means those lines must be parallel or skew, because then we're talking about two different planes, and we don't get into that. It's more of a geometry thing. So no solutions, parallel lines. They have the same slope at different y-intercepts. One solution means the two lines will have different slopes. Once you have different slopes, the lines are guaranteed to touch at one point, so it's one solution. And basically we're looking to see where the two lines cross. And then you have what happens if they have the same slope and the same y-intercept. Well, then we're talking about the same line, and that's infinitely many solutions. All right, so going back up, a guidance counselor meets with her students to discuss their plan for after high school, which is called the goal meeting, and to work on the students' college application meeting. Each of these meetings is scheduled for a specified time block. Let G be the length of a goal meeting. So we're talking about the time of a goal meeting, and A be the length of an application meeting. I'm going to have to make this smaller, or it's going to be kind of painful to write. All right. On one day, the guidance counselor has 5 goal meetings. So that would be 5G and 2 application meetings, 2A. This takes up 165 minutes. There you go. There's an equation. If the goal meetings are scheduled for 25 minutes, how long are the application meetings? Now remember, this right here is fixed, the time. So they're saying if you have the goal meetings are scheduled for 25, that would be G equals 25, or right? Yeah, 25. And we would have 5 times 25 plus 2A must equal 165. Well, 5 times 25 is 125 plus 2A equals 165. Now this is just a 2-step linear equation. We first have to peel off the number being added by subtracting 125. You get 2A equals 40. Okay? And then divide by 2 and you get A equals 20. So when G is 25, A equals 20 minutes. Okay? Now they say, okay, now what happens if the goal meetings are scheduled for 10 minutes? How long are the application meetings? So now they're saying, do this again, but now G equals 10. So it's the same exact process that we were doing before, okay? So we're going to say G equals 10. Now, it will be 5 times 10 plus 2A equals 165. So that's 50 plus 2A, that's a 50, equals 165. Subtract 50 and you got 2A equals 115. And then 115 divided by 2 happens to be Let's see, what is 115 divided by 2? It is 115 divided by 2 is 57.5. So when the goal meetings are 10 minutes, scheduled for 10 minutes, then you have about an hour for the application part. A equals 57.5. All right? So you see, as we change G, we change A. Now, find another possible length for each type of meeting that fits this situation. In other words, you are free to choose. The easiest way to do this would be to say, okay, let G equals 5 minutes. And then just go through the steps. You got 5 times 5 plus 2A equals 165. So you got 25 equals plus 2A equals 165. Subtract 25, you got 2A equals 140, and A equals 70 minutes. That's if you only allowed G to be 5 minutes. So if G is 5 minutes, A is 70 minutes. All right? Now, how many possible solutions are there to this equation? Infinitely many. Theoretically. Actually, maybe I shouldn't say, I'm going to say infinitely many. All right? So what we're doing is pick G, solve for A. Or you pick A and you solve for G. That's what we did here. Notice we had 2 variables, so the key thing to get from this is one equation with 2 variables has infinitely many solutions. All right, that's the key step. That's the key piece of information. Now, let's try the next one. The next week, the guidance counselor has 10 goal meetings. So let's go to 10 goal meetings and 4 applications meetings scheduled. This takes up 330 minutes. That's the equation. This is a G in case you can't read it because my G looks a little pathetic. All right, look at the 3 possible combinations we got before. They're referring to this one where G is 10 and A is 57.5. This one where G is 5 and A is 70. That's the one I made up. And this one where G is 25 and A is 20. All right? Look at the 3 possible combinations of the meeting length using questions. Which of these also works? So let's try each one of these. So we're going to do the first one that we got. G is 25, A is 20. So we're going to look at, we're going to look at G equals 25, A equals 20. And we get this, 10 times 25 plus 4 times 20. The question is, does that indeed equal 330? Well, 10 times 25 is 250. 4 times 20 is 80. And 25 plus 80 is indeed 330. It works. You get 330 equals 330. That point works. So let's try the next point, which is G is 10, A is 57.5. So G equals 10. And it's going to be the same deal. We'll have 10 G is 10. Okay, plus 4 times 57.5. And does that equal 330? So 10 times 10 is 100. 4 times 57.5 is a number that I don't actually know off the top of my head. It's 230. So we have 100 plus 230. So yes, indeed, we get 330 equals 330. Both those points work. All right? in the second equation. So let's try, or the second point. So let's try the third point. And I'll do it right here where it was g equals 5 and a equals 70. So it was 10g, so it will be 10 times 5 plus 4a, which is 4 times 70. Does that equal 330? Well, 10 times 5 is 50, plus 4 times 70 is 280. Almost said, and does that equal 330? And 50 plus 280 is 330. You notice, every point that was a solution of the previous equation is a solution of the second equation, which means they are solved as created by the equation. What do you notice? Okay, so basically, we had two equations. We had 10g plus 4a equals 330, and we had 5g plus 2a from the problem 1. 5g plus 2a equals 165. Do you notice that the coefficients in front on the left in front of g and a are exactly half of the coefficients in front of g of a of the yellow? And not only that, on the right side, 330 and 165. 165 is exactly half of 330. So what does that mean? That, what do you notice? That the blue equation, the second equation, is exactly half of the first equation, or the yellow equation, all right? They're half. In other words, if I multiplied the top equation by a half, we would get 5g plus 2a equals 165. They're the same equation, only difference by multiplication of a constant. It is so they are the same equation. Okay. It is getting close to the end of the school year. The guidance counselor needs to schedule 15 goal meetings and 6 application meetings in 480 minutes. So you need to set 15 goal meetings plus 6 application meetings in 480 minutes. Is this possible? Why or why not? And it is not possible because if you go through the steps of seeing, it's not possible, not enough time. There is not enough time. Because we already know that if we look at how do I say this? I want to say this correctly. So if we look at this 5g plus 2a equals 165, do you notice that the top equation is 3 times on the left here? If you look at this, right? 15g is 3 times 5g. 6a is 3 times 2a. That means 3 times 165 should equal 480. And if you do that, 3 times 165 is not, that's the wrong one. 3 times 165 is 495. So, not enough time. The blue equation is 3 times the green on the left, on the variable side, So 480 should be equal to 3 times 165. But that's not true. So it doesn't work. You can't do that. All right? So here are the rules. Scaling an equation produces an equivalent equation, the same equation. So if you multiply both sides by a number, one of the equations by this, a number, all three pieces, usually the x, the y, and the constant, you will end up with the other equation, which means they are the same equation. If a system has two equivalent equations, then the equations represent the same line. The same line and have infinite solutions. If elimination produces a false statement like 0 equals 5, then the system has no solution. We talked about that. And if elimination produces an always true statement like 0 equals 0, then the system has infinitely many solutions. So determine on number 1 if the system has 0, 1, or infinitely many. Oh, I'm going to pause here. This is the check your understanding. So I'll pause this and then I'll start again.